Hello, all my friends. So now I'll be talking about the atmospheric chemistry, why it is important, and then what are the future research opportunities in this field. When we say about the atmospheric chemistry, the three things we need to remember, that is like different things get emitted into the atmosphere, they get chemically transformed or physically transported, and then finally they will emitted out of the atmosphere or removed out of the atmosphere through deposition processes. So these three things we always have to remember. So emitted, chemical transformation, and then physical transport, and then finally the removal. Once the chemicals emitted into the atmosphere, they undergo a variety of reactions. So one of the reactions they undergo is with the radical of OH. OH radical or hydroxy radical, what we call it as. It is one of the important radical species in the atmospheric chemistry, which is also called as the detergent of the atmosphere, which cleans up all the dirty chemicals what we emit into the atmosphere. OH radical is produced by the photolysis of ozone in presence of water. It will be produced, and then once it is produced, it reacts with the volatile organic compounds. For example, volatile organic compound, if you take methane, it reacts with methane to form the methyl peroxy radical in presence of oxygen, and then methyl peroxy radical, when there is nitrous oxide NO, it will form the NO2 and then methyl oxy radical. That methyl oxy radical, once again, in the presence of oxygen, it will form the peroxide radical, hydrogen peroxide radical. The hydrogen peroxide radical again will be converted back to hydroxy radical. So this is a complicated cyclic mechanism, happens all the time. And once the NO, that nitrous oxide, while converting RO to the alkyl peroxide to alkyl oxy, gets converted itself into NO2, nitrogen dioxide. That in presence of light, it forms the NO and singlet oxygen atom. That oxygen atom will combine with oxygen molecule to form the ozone, which is the only pathway of forming the ozone in the lower atmosphere, what we call it as the troposphere. The ozone, why it is important, the ozone? Ozone in the troposphere is not good for health. It is responsible for the photochemical smog. It is responsible for the formation of the peroxyacetyl nitrates, what we call it as PANs. And then it is responsible for the health issues related to the asthma and respiratory problems. And also, it is a very strong oxidizer which will change our genetic chemicals also. So in that way, to know what is the production efficiency of the ozone in any particular area, we need to know what is the concentration of the hydroxy radical, what is the concentration of the NO, nitrous oxide, and what is the concentration of the VOCs, volatile organic compounds. These emissions are different for the urban area and different for the rural area. In the urban area, the main emissions take place through the transport system like car and vehicular transport. In the rural areas, the main emissions are from the plant emissions, biogenic emissions, what we call it as. So depending on the emissions, this chemistry gets more and more complex. At the same time, we also have the aerosols on the other side. So aerosols are produced in the atmosphere through secondary chemistry, and also they are emitted directly in the form of dust or water droplets or the salt droplets, salt dust. So those kind of aerosols, they will form the surface for the chemical reactions. They will also actively participate in the chemical reactions. Now these aerosol particles will be ready with all the constituents deposited on them. They will catalyze the reactions, and then they will accelerate the chemical transformations. All in all, if you want to study the atmospheric chemistry, first of all, you need to know the chemical composition of the atmosphere. Second thing, you need to know quantify all the chemical composition. Third thing is, you need to use the computational models to better understand the chemical processes. What we do in the computational models is, like we put the input parameter of all these chemical compositions, their reaction rate constants, and then meteorological parameters like humidity, temperature, light intensity. These kind of things we put into the computational models, and then we give all the chemical parameters there, and then we give all the transport systems there. Then the models will predict the whole chemistry outlet. So this chemistry output we can judge with the field measurements. If you go to a particular field and then you measure the ozone concentration, and then you try to run the chemical computational model, and then what is the output concentration of ozone it is giving for that particular location, and what exactly you have seen from the field, you intercompare them, and then if they are agreeing very well, then that means that your computational model is validated. Now then that computational model can be used for the prediction of the future air quality. So likewise, atmospheric chemistry is a multidisciplinary talk. So you need to have the analytical chemistry background, you need to have the chemistry background to identify different compounds, you need to have the meteorology knowledge, you need to have the physical knowledge to understand the transport system and all, you need to have the computational model, that computer knowledge to run the computational models, and also you need to have all the meteorological data. So if you are having any expertise in any of these fields, you can become an atmospheric chemist. So in India, unfortunately, the atmospheric chemistry is not very well being done, research being done in it. So there are a lot of institutes, they are trying to set up the atmospheric chemistry research, but not it in the full-fledged. So there is an ample of scope for the students who are seeking for the atmospheric chemistry research. So they can always find a good future in atmospheric chemistry field. For example, the OH radical, what I said, the computational model predictions are like 4 times higher than the reported concentrations elsewhere in other countries like Europe. But in India, the models predict that they are 4 to 5 times higher than the reported concentrations in other countries. But we don't have any ground truth to validate this hypothesis given by the models. So this is one of the examples I am giving. We can do a OH measurement in India. That would be a very good science work we are contributing to the atmospheric science research. Like this, there are other gap areas, like many of the rural places in India, we don't have any atmospheric chemistry data. Like ozone, we don't know what are the NO and NOx concentrations, we don't know what are the volatile organic compounds in the rural areas, we don't know, because even the agricultural fields in the rural areas, they also emit some kind of volatile organic compounds. Even the vegetation there, they also emit some type of organic compounds. So this knowledge will be really useful to predict the air quality of that place. If it is very good, then we can take it as a reference. So this is the air quality we should have in all the places in India, and then we can try to mitigate the policies so that government will take some step action on curbing the air pollution problems. You may be knowing that Delhi is ranked among the worst in terms of air quality in the world. So this is really unfortunate thing for us, because we are being in India and then Delhi ranked as the most polluted city in the world. So there is no worse scenario than this. Now we should take this air pollution and then atmospheric chemistry problems very seriously and try to understand them, and then try to curb the air pollution in India, so that we will all have a healthy air to breathe, and then our health system will be very good. We don't have any problems. Thank you very much.